Hi, my name is Karis Park, and today we're going to go over Descartes' rule of signs. So we use this when asked to determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros for a function. So step 1 is count the number of sign changes. And sign changes are when it goes from positive to negative, or it can be vice versa, which is negative to positive. And this is going to be sign changes in the f of x, the function. So after you do that, you're going to subtract 2 to that value being the sign changes. And make sure to not get negative values, because you cannot get negative possible roots. So meaning that if I got one sign change in f of x, then you have to subtract 2, as I stated right here, but I would get a negative number. And you can't have that because obviously you can't have a negative number of possible roots. So this shows the number of positive real roots. So if we look at this problem here, if p of x has 7 sign changes in p of x, the possible number of positive real roots is 7, because it stated 7 sign changes, and then you would subtract 2, and then you get 5. Subtract 2 again, you would get 3, keep going, and you get 1. And obviously, as I said before, you can't subtract 2 from this because you would get a negative value, so you stop at 1. Now step 2, count the number of sign changes. So again, we went over positive to negative or vice versa, but the difference is that it is an f of negative x. So wherever you see an x, you're just going to put a negative in front of it. So the number of sign changes in f of x, you're going to subtract 2 to that value. And again, make sure to not get negative values because you cannot get negative possible roots. So this would show the number of negative real roots. And let's look at this problem. If p of x has 4 sign changes in p of negative x, the possible number of negative real roots is 4, and then you would do minus 2, which is 2 minus 2, 0. And obviously you cannot do minus 2 because then you would get a negative value. Now let's look at a real example. F of x equals, and it's this whole thing right here. So in order to find positive real roots, you would just do the sign changes in regular f of x. So if we look here, this is positive, negative, so that's 1. And then there's negative, positive, 2. Positive to positive, that doesn't count as a sign change. Positive and negative, that's a sign change. And negative, that's not a sign change. So overall, we have 3 sign changes, meaning that there are 3 positive real roots, or you can do 3 minus 2, as I stated over here, subtract 2, and you would just get 1. So it can be 3 or 1 positive real roots. All right, so now in order to find the negative real roots, you would just do f of negative x. So then wherever you see an x, like over here, you would just plug in negative x. So I did that over here, and you would just look at the exponent and see if it's odd or even. If it's odd, that means that it would keep the negative sign, and you would see if this is positive, and since it's an odd exponent, it's going to be a negative, right? And then if we do the 4th power, which is even, so this negative would not be there because it's negative times negative times negative times negative. This is a positive, this is a positive, and positive times positive equals positive, meaning that you would just keep this sign that is in front of 8x to the 4th. And you just keep doing that by seeing if the exponent is even or odd. So now that I come out with this simplified version, you would just see the sign changes. So this is negative and negative, meaning that there's no sign change. Negative, negative again, and then negative to positive, that is a sign change. So that's the first one. And then positive, positive, no sign change, and positive and negative, and this is a sign change. So there are overall 2. So there are 2, this should say negative real roots, or, so I did 2 minus 2, which is 0, negative real roots. So let's fill out this table. So positive real roots, as we found over here, we said that there are either 3 or 1. So if we put 3 or 1 here, and then we also said that negative roots, there are going to be 2 or 0. So now we need to find every possible combination of the PRR and the NRR. PRR is positive real roots, NRR is negative real roots. So since the 3 and the 2 are matched up and 1 and 0 are matched up, now we have to switch it up. So now we're going to rewrite the 3 and the 1 for the positive real roots. And since we already did 1 with 0, we're going to do 1 with 2 now. And since we did 3 with 2 already, we're going to do 3 and 0 now. So now if we look, before doing the imaginary, we're going to do the total first. So the total has to be the number that is the highest exponent in the function. So if we look here, it's 5, 4, 3, 2, 1, and then there's no exponent here. So the highest exponent is 5, meaning that this function crosses the x-axis 5 times. So it can be 1, 2, it can be 1, 2, 3, 4, 5, or it can be whatever. But yeah, it crosses the x-axis 5 times, so it has to be a total of this. But there can also be imaginary. So with the total possible combinations of the positive and negative real roots, we can find out the imaginary. So if we do the total, which is 5 for every single one, minus, and then we're going to add up the we're going to add up the positive real roots and the negative real roots. So it's 3 plus 2. And this is going to be 0. So 5, and then the next one is 5 minus, and then 1 plus 0, which is 4. 5 minus 1 plus 2, which is 2. And 5 minus 3 plus 0, which is 2. So this is your overall chart, and this is how you answer these type of questions. Thank you for watching.